Hello and welcome to the Tandes YouTube channel.
Whoa, we made it! This is a great day today because Roger and his family are here to visit Germany. Roger, of course, even if it's his holiday, he took the chance. Today we are going to show you the production of the Tandes company through Roger's eyes. We are today manufacturing a Osmolator 3 for you.
Yeah, I look forward to it. It's of course, the Osmolator has long been one of our best-selling products. It'll be exciting to actually produce one beginning to end.
I'm especially excited to see Roger with the soldering stick. Okay. So our first stop is here in our machine shop. Basically, we have 5 mold injection machines here. This is in our tradition. I'm getting the boost bump moments already again because I'm loving the space. I love the smell. I love the sound. This is where we craft, this is where we make most of our plastic parts. Around 1 million parts we manufacture by our own here, and of course all the parts for the Osmolator are also made here.
Here we have the molding machine producing the lens cover of the Osmolator 3. As Felix mentioned, I love the smell here. I did some math last night and realized that I've probably spent a year of my life at this factory. It's a smell that smells like home, and just an interesting story. Sometimes customers complain about the smell of the plastics when they open the box. For one, it reminds me of my second home, but the other thing is, as a child, we used to have injection molding machines at zoos, and you could get a print of an animal from a molding machine right by the animal's cage. The San Antonio Zoo actually still has these. It had a very distinct smell of freshly molded plastic, and so it brings back warm childhood memories to be around these machines.
In this step, we manufacture the complete housing, including this tip here, where we will later install the thermal sensor, and this cone here for the optical sensor.
So this must be optically clear for the infrared light to shine through, and then the rest is just frosted as more or less a decorative look.
Here you can discover one thing: we don't manufacture the molds by ourselves. We are in Germany. Germany is a powerhouse of manufacturing. Not only we have the manufacturers for these machines around us, but also the mold makers. They make hundreds of molds a year, so they are deeply into it. They have very specialized machines. This mold, for example, is from Hubert Wörnle Werkzeugbau, a very traditional and very Bavarian supplier, but I love this relationship to our suppliers here around us. Okay, and on this smaller machine here, we are manufacturing the impeller of the HIS that will later push the water in your tank when the sensor recognizes that there is not enough water. By now it looks a little bit naked.
It's actually a fascinating process. You use the ultrasonic welder to finalize the assembly. Having done this step, it's really interesting. You put on these protective earmuffs and you just hear and it uses a high frequency sound to weld the parts together.
So this process will of course be shown later. One thing that is important, the plastic we are using here, we know also for years now, it's exactly the same plastic we are using in this bearing disc of the Stream 3, and of course we are using the same shaft, the same bearing method we are using on our pumps for decades now. So this again, manufacturing our own pump works, not only because we have the machines here, but also we have the experience to do it great. So for you at home, these are our molds. Some of them are, let's say, older than my father. Some of them were manufactured under the lead of my grandfather and still in operation. Some of them are very old, but still in the good old days of made in Germany, they made them in a way so they still work today and we're still using them. It's really for the parts you all know. Here, this is, for example, the mold for the old Osmolator Nano. Here we see some parts we are using for the HIS as well. But
the one thing I mentioned was that when you watch, if you go on YouTube and look up the Lego company, they show one of their factories stamping out all the Legos. They use this exact same brand of molding machine, and for as long as I've been here, since a lot of these parts, like a lot of people know this is the back of the 9004, the 3162, 3163, and weight box 6208. And so we refer to the parts as our Legos. And when we have a concept, it's like, can we build it with the standard Legos? Do we need to design a new Lego? It's kind of a childhood continuation.
Investing in a mold is expensive. That's one of these hurdles for smaller companies. But as soon as you have a mold, you can basically manufacture as many parts as you need. If you can construct them in a way they are used for many purposes, then you save a lot of money. And for talking about costs, I mean, building these molds here in Germany is expensive. For very, very easy molds, you only pay 10 grand. But let's, for example, here we have molds like this for the HIS. They have a hardened surface. We have the thread here. So this is more like 35 to 40,000 euro. It depends on the mold maker. Sometimes they are very efficient and they don't waste steel, and some suppliers waste steel and build huge molds for small parts, unfortunately. So here is also something that might interest you for the future. As we have the mold, these molds are also always there living. We are changing things all the time, and this is already, you see, this is the HIS we used to manufacture for the osmolator, and this is the next generation. You see this area here where the water is pushed out of the turbine, of the impeller, and here you see it's much larger. This will increase the efficiency and make it less noisy, and also we are, you know, experiencing with different plastics. This, for example, here is food grade, very, very acid resistant for other industries. And this, for example, you can also do it in transparent. Actually, we are thinking about creating a DIY pump for cooling your CPU and your computer. This could be also an interesting thing for us, as of course we are an aquarium company, but also we are a pump manufacturer. So in here we are storing all the plastics we are using for our parts. And there's something quite interesting. Imagine you go to a restaurant and it's healthy food and it tastes great. And this is most likely because they are using high-grade ingredients. I mean, this is what we are doing here. For example, for the osmolator, we are using Makrolon. It's really a German plastics, a traditional German plastics, and it's really made in Germany. For the sensor that we showed you, there are other plastics for every special purpose. There is a different plastic. For example, this one here, this is our secret ingredient for the blades of the care magnet. Just imagine 1 kilogram is more like 25 euros. So this pellet with around 1 ton is 25,000 euros. So this is super expensive compared to other plastics that are more like 4 to 8 euros per kilogram. So here we don't save money because we know that high-grade materials are essential to make great premium products.
So I got a brief walkthrough of the production of the Osmolator 3. The main thing that struck me is the high amount of hand labor. When Apple tells you we couldn't make our products anywhere except China, well, clearly you can. Maybe it's not as much as an iPhone, but there's a lot of labor here, and it's quite impressive. The first thing we do is we make this will be the second quality check of the lens. We're looking for any blemishes in the safety sensor, any cracks or defects in that housing, and then we're just checking that the lens and everything is good to go. Then our second step is we're taking the safety sensor and we have to dip it in a UV curing resin. So we just dip it in there, place it down in, and then when we push it down in here, the resin is cured. Takes a few seconds. There's a sealing boot that we need to push down. Then we apply a first layer of insulating heat shrink. Need to let the wires cool down a bit so we don't melt the second layer. So this is the PCB. These are designed by us, but they're produced by a circuit board producer in Saxony, Germany, which I'm told is the Silicon Valley of Germany. We have to get these safety sensor posts to go through these contacts here, and then slide it onto these guide pins that make sure we have a perfect alignment. So there we go. Now that that step's done, we need to solder. They have this nice workstation, keeps it steady. This is actually new to me. I've never used such a soldering iron. It automatically feeds the solder. It's kind of convenient. Before, I want to just double check that we're completely on the guide pins. Everything looks secure. Now we need to trim. Next step is the strain relief grommet goes in. This protects the cable and helps seal our entrance. All of this gets potted with polyurethane, so in general these pieces are more in place to protect the cable from the sharp edges of the plastic. We'll make it easier for ourselves by making sure it's secure and rounded out. Now we need to take one of the cables, feed it through. We've got 5 wires, 3 are for the pump, 2 are for power. We'll get it started. Now we need to wet the cable. We just use water. Helps it slide through without pushing the grommet through. And we need to get our wires. And there we are. So now we need to manipulate our wires out of the way. Now our wire positions are labeled blue or blau in German. So we need this wire over here, brown. Then we have gelb, which is yellow, rot or red, and schwarz. Probably our best next step is to get some solder flowing on these, so when we're ready we can work quickly. Okay, so this assembly's done. Now we make a test. It functions.
First own build osmolator.
Yes. So even though you can see I got it and it worked, it was a very tedious process. Not only that, but I damaged the cap, even though this isn't a part that would be covered by PU resin and wouldn't affect the function. My 2 big mistakes were I had the cable rotated 180 degrees of where it should be, so I had to manipulate the wires quite a bit. I definitely put too much solder, not that that necessarily hurts anything, it would be stronger joints. But then on top of it, I melted the cap in 3 positions there. So it definitely takes a lot of skill, and I would say you're definitely getting your money's worth on this product. That's a lot of work. Now we've got to build our high-jet pump for the Osmolator 3, and this is the 3 pieces of the rotor. It's actually 4 pieces, but we're starting out with this already assembled because this template on the ultrasonic welder has to be changed. But I did want to show the basics of how this is assembled. We have our molded plastic shell, we have our magnet, and we have the actual base of the turbine. Here we've got the magnet already in the shell, and what's notable about this is a lot of times manufacturers in our industry use a nickel-plated magnet, and that's one of the main sources of toxicity if this were to ever fail. While we're using an extremely hard, durable plastic that should never fail, the magnet inside does not have that nickel plating. We specifically ask for that from the magnet supplier to avoid any toxic elements getting into the aquarium. So this is that subassembly that in our case is already made. This ultrasonic welder generates a very high pitch frequency, which is damaging to your hearing, so you have to wear ear protection. But we take this cap and everything has to line up properly. There's a groove system in there, so you can feel it clicks in and you've got it right. Then we place it into this template. We push the button, and when it's done, it's done. You know, such a machine, it can cause injury, so this isn't for just playing around. If it were to get on your hand, I mean, it can definitely hurt you. So it's a precise process. That's how these are assembled. There's our finished rotor. So here we're potting the assemblies of the optic sensors with the board. What's been added is the magnets. We have 2 magnets that are on an iron plate, and that bridges them so they act as a team. Then we've got the polyurethane resin being injected to waterproof it. Fairly elaborate process. You can see we have the mixing of the 2 components of the resin, and it's being injected very evenly, side to side. We need to make sure that there aren't any bubbles, that everything's even and stable, and it goes in stages. So the first layer sets up, then another layer is added, and this is how the magnets and pumps and everything is sealed. This is a very secure way to seal things up, and you can also see that the resin clears as it sets. It comes out a bit like milk.
Finally, a process where Roger has to do nothing but watching it.
Yeah, this is all very precise by a robotic system.
Yeah,
so.
you can hardly do it by hand only because you would never match the timings. You would almost every time overfill it or have not enough resin in it, and then this would be a mess and expensive.
So this is an interesting step I wasn't even aware of, but this is another quality control step. After the first layer of the PU resin is added, it goes on this special mirrored setup. It actually is using one of our LED lights, one of the EcoChic lights. We search for bubbles, any blemishes are addressed. So here we've got a small bubble right at this cable grommet. We have to manipulate the resin to get it out. And there we've got it rising up. So the bubble's solved. And all the other units, there is one more over here. And this ensures that we get an even seal, that there's no possibility of intrusion, that everything is completely potted and sealed up. Another interesting thing to note is that this room is unique to the factory in that it's extremely climate controlled. It's quite cold in here. And you can see there's all sorts of instruments to measure the quality of the environment. This is a noise monitor, make sure that we're not at a dangerous noise level, because there's so many machines running and everything in here is a very precisely controlled environment.
This is actually also, again, something special here. Since we are a pump manufacturer, we decided to go all in with our own pump for the Osmolator. There are a lot of ATOs there out in the market, and the manufacturers behind them, you know, they simply buy the pump.
It's generally been the Achilles heel of any ATO, is pump failure.
Yes.
So
that's why we decided to do it our own with the tools we have. And you can hear in the background our coil winding machine. It's doing its job here again. Here we went a very special way. We used the coil of the Stream 3. We were very familiar with it already and downsized it in a way that it fits to this tiny motor. It is running very, very fluently.
It doesn't click between poles. It's a 3-phase design.
Yes.
Here we have the cores of the coil. These are basically a ready-made template that the machine uses to wind up the motor coil. There's already several steps that are done. So we've already got our power connection point. The core and the shaft has been pre-assembled. That shaft has to be pressed in, and that's a step that's done here at the factory. We insert these, and there's a specific alignment. There's a groove that they have to align on. You can see this is a collet, and once they're in, they lock in. And then we have 2 buttons that have to be pushed at the same time for safety. Door shuts and the machine starts. Okay, so now we're progressing with building our high-jet pump. We've got our coil. Now I need to solder all of the coil contacts. These take a little while. You have to flow a fair amount of solder, and it has to wick through completely to make good contact with the solder pads. We'll start here. And like so many things here, they have tooling that they built themselves to perform these tasks. So we've got a nice template that we can spin the coil on and work our way around. Now we need to prepare these pads for attaching our cable. In this case, they already threaded it through the housing. I was taught that you start with the black wire where the screw is, then we move forward to red and then yellow. So now we have our coil. We can see that we got good wicking throughout. Everything's good. We want to check that there's no stray copper filaments that we need to trim. Everything looks good. So then we take our motor. This is the actual housing of the motor. We already have a core in here, which acts as basically an EMF shield. Then we have a notch, and that has to line up with a notch in there. We put this in, and there we can feel we're engaged in the notch. Then we have to put this housing, and this only fits one way. This step's done. Now we have to make a test run. So this is our test device. Again, a lot of house-made instruments, and it works. So once we were sure it works, then it can go on to be potted and the assembly finished. One of the last steps before we package it is we do the quality test. Here we're doing a final check that everything works properly, and this is the actual test station. This is actually how they're all done, one by one. The first thing we do is we connect our pump. Here it's slightly modified, so it just plugs together quickly. We don't have the thread lock. You can see we have a pump inside this tank, and it has a thread as a marker to let us know that it's actually flowing. We connect our power. We wait for this to initialize. It usually should be done in about 30 seconds. Now we have our blue light. The next thing we check is that the pump's driven properly. We should have a couple of brief pulses as it primes up the pump. Once we get a continuous flow, we can verify the driver's operating properly. Then we submerge it fully. We should get a red light and the pump should stop. So our safety sensor works. Then we bring it back up. We should get a green light. And then when we take it back out, we should get a blue light and it pumps again. We can verify this unit passed and it's ready to ship. So here's the last step, packaging. Normally this is an extremely busy situation. There's tons of boxes, tons of products, but I'm just showing how one is done. We have our preformed box. We fold up the sides. Now we have our insert. This was already formed for me. We take a magnet, sensor. Since we're producing our products in the European Union, single-use plastics are out, so everything has to be packaged in a manner that the materials can be recycled. We place in our pump, tubing, power supply, add our safety warning about the magnetics, manual, warranty card, finished. If I were to give my general overview, this is the first time I've built an Osmolator 3. I think more than anything, I was impressed with how much hand labor still remains. So even though you have all this machinery and equipment, there still are a lot of steps and a lot of hand labor and a lot of things that have to be done just right, very precise. And that there were so many steps along the way of just checking your work. Even after this, somebody else would even check this step, putting the seal and making sure that everything was done right. You have a lot of redundancies, and I know sometimes people are like, well, what do you mean? I told you it's broken. And I was like, I know how many steps go into this stuff, and so let's first check that everything else is covered. So
we do so much redundancy and quality inspections. Actually, really very often when influencers like Roger are visiting us, they are always impressed how many redundant quality control checks we have. And this is especially for you guys at home, because we don't want product lottery. It is a product lottery. Imagine you just bought your new osmolator, you bring it home, you want to install it on that weekend, and it fails. This should never happen. And as a premium brand, this is our goal, to bring you a premium product that lasts and that simply works. Especially the osmolator is a product where you have to trust and where you have to rely on, and that's why we take so much efforts to build it. If you want to see more about the production of this company, there are more videos out there. We put you down in the description some links if you want to see more. And until then, see you in the next video. Enjoy your tanks. Bye!